In today's video, we will understand and memorize the distinctions between the elimination-addition mechanism versus the addition-elimination mechanism. So both of these involve starting with an aromatic halide converting into an aniline or a phenol. But one will have a benzyne intermediate, and this one will start with the elimination followed by addition, whereas another one will not have a benzyne, but the reaction mechanisms are similar. The only reason why it doesn't have a benzyne is because it's ortho-substituted. So if you have a meta or a para-substituted halide, you would go with a benzyne reaction mechanism, but if you have an ortho-substituted, then instead of having room for that alkyne on our benzene, that alkene or alkyne is going to move its bond over on this nitrogen, so we'll do that in a second. But the difference is this is an addition-elimination mechanism. So the exam will ask you to draw one of these and make sure to know the distinctions. But otherwise, the reaction mechanisms are based on the same principles. So let's start by drawing this one. Because we have a monosubstituted halide, we can start with an elimination to get a benzyne intermediate. To eliminate, we use a base, attack hydrogen, who donates its bond to make an alkyne within the benzene ring, thus eliminating the halide. So now we have an alkene inside a benzene, so it's a benzyne, which has resonance structures through charge separation. I have another video just on everything you need to know about resonance and charge separations. I think it's kind of cool. You should check it out. Okay, so these are our resonance structures. We want to add an amine on here, so we will take the NH2 nucleophile and attack it at the area of positive electron density. So it could be there or it could be there. So we will have two different products. But we still keep a negative charge here. But that's why we needed to use a proton source so that we can protonate that negative charge. And there is our aniline. Let's say if this were para-substituted. Let's say there was a methyl down here. And the exam might ask you, draw the mechanism that turns this into that. But it has two products. So a para product and a meta product. So then you would not think nucleophilic substitution because methyl is an ortho para director. But here we got a product that is ortho and meta. So then you would think, oh, this is aniline. That must mean it must have been created via the elimination-addition mechanism and not by nucleophilic substitution. Okay, now let's try an addition-elimination. So the cue to use addition first is because we have an ortho-substituted halide. And for this kind of mechanism, make sure to do some proton accounting. So this has positive formal charge, this is negative. We start by addition, which is taking the base. So right now we're making phenol. We can make aniline as well, but I chose phenol for this example. We add it to this position. So to respect the octet rule, we must push this bond over. And to respect this octet rule, we push this bond over. Now we have a double bond. Make sure to check your formal charges. Okay, so this is neutral, but now this is negative. So that was our addition. Now we do elimination, and this is our negative charge. We can push it back, So this bond can reform that benzene and thus eliminating the halide. And that will give us our product. This is once again positive, this is once again negative, so now it is neutral. Okay, so main takeaways here is the exam will give you the starting reagent and the product and ask you to identify the mechanism and draw it out. So then first thing to think about is, does it look strange? Is it a phenol and an aniline, but that is in two different positions, but that is, one is maybe para to a substituent, one is meta to a substituent, but that substituent is ortho and para directing. So anytime you go from halide to aniline or phenol, you might think about elimination-addition or addition-elimination. And make sure to recognize that if it's an ortho substituted aromatic halide, then you use addition-elimination. And make sure to memorize these conditions as well. If you forget the second protonating step, that will not be very good.